Good afternoon, class. Here's Chapter 3, Derivatives, Section 3.5, the chain rule. Here's the first part. So we covered derivatives and rates of change, derivatives as a function, basic differentiation formulas, the product and quotient rules, and now we're going to move on to the chain rule. Reminding you, if you have a curve and 2 points, the slope by definition is rise over run, delta y over delta x, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And as you can see, we can write them in various formats. That's known as the average rate of change of y with respect to x. When we take a limit at a specific point, for example, a, f prime of a can be found, and that represents the slope of a tangent line. Equation of a tangent line at this point would be y minus f of a is f prime of a times x minus a, or just use the point slope. So delta y delta x, average rate of change of y with respect to x. If we take a limit and we let delta x go to 0, we call it dy dx. In essence, f prime of x, the same thing, the limit of f of x plus h minus f of x over h as h approaches 0. So that's the definition we started. Now, there are some formulas. For example, the power rule indicates the derivative of x to the power of n is n x to the power of n minus 1, and it gives rise to the derivative of constant is 0, k times x is k. And then we have the exponential rule. The derivative is itself. The derivative of sine is cosine. Derivative of cosine is negative sine, and the rest of the trigonometric functions, the derivative of tan is secant squared, cotangent is negative cosecant squared, secant is secant x tan x, and cosecant is minus cosecant x, cotangent x. And there are other rules here. For example, the constant can come out, or the derivative of the sum is the sum of the derivatives. The same thing for the difference. Then the shorthand notation for a product rule, fg prime is f prime g plus g prime f. And for a quotient rule, f over g prime is f prime g minus g prime f over g squared. Now we're going to go to composite function. F og is f of g of x. And if we want to differentiate that, we use the chain rule. Becomes f prime of g of x times g prime of x in Leibniz's notation. dy dx is dy du dx. This is the synopsis of the chain. So to get us started, let's go with the composite function. So section 3.5, the chain rule, the composed function FOG, the composition of f and g, is defined as FOG equals f of g of x. So as a warm-up example for the given functions, we want to find FOG as well as g of f. So starting with f of x equals x cubed, and we're going to go with FOG by definition is f of g of x, which means f of 1 plus x squared. Normally, we skip this step, and we put that into this. We get 1 plus x squared to the third power. And you don't have to raise it to the third power. This one is g of f of x, and that means g of x cubed. Replace it here. Now, this 1 plus x cubed quantity squared, you have to rewrite it as 1 over x to the power of 6. And as you can see, FOG in general is not equal to g of f. If f and g are two functions that are inverse functions, then they become the same. F of f inverse of x equals f inverse of f of x equals x. Two composite functions can result in the same thing if the two functions are inverse of each other. So having said that, let's go with the chain rule. How would you differentiate y equals square root of 10x plus 5, or f of x equals 10x squared minus 1 to the power of 50? And the answer is the chain rule. So what is the chain? The chain rule, if g is differentiable at x and f is differentiable at g of x, then the composite function f of g of x is differentiable at x. So d dx of f of g of x is f prime of g of x times g prime of x. Meaning, if you want to differentiate the composite function, first you differentiate the outer function, the main function f prime over the inner function g of x times g prime of x. This is the one that actually makes it a chain rule. Now, if we go with the Leibniz's notation, and y is f of u, that means it's a function of u, meaning u is the independent variable. And u is g of x, that means it's a function of x, and x is the independent variable. And then dy dx is dy du du dx. Or, as it was mentioned, let capital F of x represent the composite function f of g. And if you want to differentiate it, you get f prime of g of x times g prime of x. That's what we get, everybody. And so that's the synopsis of the chain rule. As an example, what is the extended or the general power rule? First, I want to remind you the power rule indicates the derivative of x to the power of n is n, x to the power of n minus 1. What if we have g of x instead of x raised to the power of n? What is the derivative of that? This is using the chain rule. So we follow the same format. We say n, then x to the power of n minus 1 becomes g of x to the power of n minus 1. So far, it's not a big deal. However, as you look at x, you know the derivative of x is 1. So if you said times 1 here makes no difference whatsoever. But over here, the derivative of g of x is g prime of x, and it makes a difference. So we have to write that. So I hope everybody is okay with that. All right, so let's look at the following examples. I believe they will help us understand this concept pretty good. So let's look at them. And when we deal with trigonometric functions, how do we differentiate them? In my opinion, if we just read them in the following manner, y equals sine, and then we pause. We say y prime is cosine, and then we're going to pause again and say trigonometric functions are meaningless without their argument, so we need the same argument. However, this is not x, it's a function of x times 2. And of course, we bring the 2 to the front. So it's pretty straightforward, everybody. For this one, we're going to do the same thing, sine. And we're going to pause. And we say, okay, again, it's meaningless without its argument. So we need the same argument. But the argument is not x or t or theta, it's a function of x. Then we need the chain rule times 2x. We write the 2x in front. The last one, to make sure we understand what we are dealing with, we are going to rewrite it as sine of x to the second power. Therefore, we use the extended power rule. 2 sine x to the power of 1 times its derivative, which is cosine x. 2 sine x cosine x. And most of you should recognize this one as sine of 2x. You don't have to change it, but that's just from trigonometry in case. We want to differentiate this, and we're going to differentiate it two ways. Y is u to the power of 5. That makes it a function of u. U is 10x cubed plus 2 makes it a function of x. We're going to call it x. We're going to go with both methods. First, we're going to do the method by Leibniz, dy du equals du dx. So dy du, just stop there and say u to the power of 5 is simply 5u to the power of 4 if you differentiate it with respect to u. Then du dx, we're going to differentiate this with respect to x, and obviously it's 30x squared. We are done. We just have to replace the u with 10x cubed plus 2. We do so. So 5 times 10x cubed plus 2 to the power of 4 times 30x squared. The product of these two sits in front. 150. 10x times 10x cubed plus 2 to the power of 4 is the final answer, everybody. Very straightforward, and we used Leibniz's notation. Now this is a composite function. Because it's easy to find the composite function, we're going to evaluate the composite function and then use the extended power rule. Now, in some instances, it's very difficult to find it. That's why you want to learn both methods. So f of g of x means f of 10x cubed plus 2. So u to the power of 5, replace the u, you get 10x cubed plus 2 to the power of 5, and you deal with that, everybody. Now, using the extended power rule, y prime becomes just, again, composite function. F of g prime is f prime of g of x times g prime of x. So it becomes 5 dy dx of y prime. Same thing, the power of 4, x to the power of n minus 1. And now we applied really the chain rule, the derivative of the inside, 30x squared. Again, we put them together, we get exactly the same answer, 150x squared times 10x cubed plus 2 to the power of 4. It's very straightforward. We're going to differentiate using the extended power rule. Y equals 10x squared minus 1 to the power of 50, so we come up with 50. Same thing, the power of 50 minus 1 or 49, and g of x to the power of n minus 1. Again, when I'm differentiating this, I would write the formula and follow it. Or just from the memory, I follow that. Either way. Now, finally, the derivative of the inside, the concept of a chain rule requires 20x. And when we put these two together, we get 1000x. And that sits in front. We are done. What about part B? Y equals square root of 10x plus 5. Well, we are going to use our algebraic techniques to rewrite it as 10x plus 5 to the power of 1/2 to make it ready for the power rule. So that means 1/2 in g of x to the power of n minus 1. The same thing, the power of 1/2 minus 1 makes it negative 1/2. A g prime, the derivative of the inside is simply 10. Done with calculus. 10 and 1/2, the product is 5. This one goes down, becomes 10x plus 5 to the power of positive 1/2, which is a square root. What about this one? You want to differentiate it. First and foremost, you have number 5, you keep it. Now you deal with this, just as you did with this, using the extended power rule. We need the 4. Then 3x minus 2 cubed, because 4 minus 1 is 3. And now the chain rule says you need the derivative of the inside. Number 3, 5 times 4 times 3 is 60. You put it in front, you're done. Exponential functions, we want to find the derivative of y equals e to the power of 10x. Reminding everyone, when you have e to the power of x, the derivative is itself. And when you have a composite function, the derivative is f prime of g of x times g prime of x. So what if the exponent is not x, but rather a function of x? So according to this, times g prime. So if you happen to have e to the power of g of x is itself, times g prime. If you happen to have e to the power of kx, you want to differentiate is itself times the derivative of kx, which is k. So how do I approach this? As soon as I see an exponential with the base e, I'm going to write exactly the same thing. Then I look at the exponent. If it's x, I'm done. It's not, I need its derivative 10. I put it in front. Same thing here. Because y is e to the power of t squared, the answer is e to the power of t squared times, the chain rule tells us we need the derivative of t squared. 2t, I put it in front, we are done. What happens here is similar. Number one, I'm going to rewrite it as e to the power of 2t. Then I say y prime is e to the power of 2t. Times what? Well, I need the derivative of that. 2, and I put it in front. That's the final answer, and I'm done. We want to differentiate y equals 5x times 3x minus 2 to the power of 4. First, I want to discuss the number 5. If this number is involved, meaning it's large, like let's say 5,000, or very small, or fractional format, or decimal, let's say it's 0.21 or 2/3, then you want to keep it out and deal with it like so. At this point, makes no difference. So what I want to do, I'm going to show you both ways. So I'm going to differentiate this and say it's a product of 5x and 3x minus 2 to the power of 4. I put a raised dot and I call this the f function, this one the g function. And use the product rule on that. So f prime is 5 times g plus g prime. Now, g prime, I'm going to use the extended power rule. I'm going to start with number 4. Then I need 3x minus 2 cubed. Then I need the derivative of the inside 3. This entire thing is g prime, and now times f 5x. In other words, I have f prime g plus g prime f. And I'm done with calculus. Done with calculus. This is not a finished job, and it's not acceptable if you stop here. I can't emphasize this enough. Even if in some cases your digital platform accepts it as the final answer, won't be happening for the exam. All right, so we are going to rewrite this one so it becomes clear what is the common factor. We're going to rewrite this one as 4 times 3, 12 times 5x, 60x times the rest of it. So it becomes easy to see 5 is in common between 5 and 60. 3x minus 2 is in common. But between these two, exponent 4 versus exponent 3, obviously we go with the smaller of the two, exponent 3. Now I'm going to divide this one by this one. Everything goes away except 3x minus 2 to the power of 1, or simply 3x minus 2. I'm going to divide this one by this one. 3x minus 2 cubed goes away. 60x divided by 5 is 12x. And all I have to do, combine these two into 15x, and y prime becomes 5 times 3x minus 2 cubed, as we had it, and the brackets 15x minus 2, and I'm done. Now, as I mentioned, if this number is involved, you don't want to go this route. Instead, I would put brackets around this, and I'm going to keep the 5, and I'm going to work on this one. And now f is x, g is the same thing. So if f is x, its derivative is no longer 5, it's just 1. So 1 times this. Plus the g prime is the same, everybody. The g prime is the same. But f was 5x, but it's now x. So take a look. G prime is not changing. F instead of 5x is x. And I hope you see this number 5 carries out here. So you factor number 5. So if this number is involved, you definitely want to go this route. It's a lot easier. Of course, this is the finish job. This is not finished. You have to continue and finish it. Either this way you finish it, or if you went with 5 being a common factor and brackets, then you continue working out by factoring a common factor, finishing up the job. What about this one? If your function is a fractional form, this is actually a rational function, but even if it's just a fraction, not necessarily the denominator is a polynomial, it makes it a rational. But even if it's not, instead of using the quotient rule, just bring this up, make it an exponent which is negative. I'm looking at negative exponential rule, which indicates if you have a negative exponent, take it down, make it positive. Okay, or vice versa. In this case, I was positive, I brought it up, I make it negative. Why do I do that? I get it ready for the extended power rule. So therefore, if I want to differentiate, I start with the exponent negative 4. Same thing to the power up. I'm going to subtract when I get minus 5. Now I use the chain rule. The derivative of the inside is 14x minus 1. Again, I'm done with calculus. The product of these two sits in front, at top, and this goes to the bottom with the positive 5 as the exponent. The final answer, y prime, is negative 4 times 14x minus 1 over 7x squared minus 5 minus x to the power of 5. What about this one? I have to use the quotient rule, so I'm going to call it f over g. So y prime, a large fraction bar, f prime is 1, and just times g. 2x minus 1 to the power of 4. Minus g prime. Now g prime, so this was a quotient rule. Now this one uses the extended power rule. So in conjunction with the chain rule, in essence, we use both of them, meaning now this one is minus 4 2x minus 1 cubed. The derivative of the inside, this really makes it a chain rule. 2. This is f prime times, this is g prime times f, which is x. We're done with the numerator. The bottom is g squared. That means square this one. How do you square this one? Just 4 times 2 makes it 8. So the exponent becomes 8. 2x minus 1 to the power of 8. And again, I can't emphasize this enough. You're done here with calculus, but you're not done with your algebra to finish the job. I can't emphasize this enough. This is important to be finished. This is not finished yet. What do we do? Well, notice 2x minus 1 is in common. So we're going to make 2x minus 1 to the power of 4 versus 3. Which one? 2x minus 1 cubed as a common factor. So if I divide this one by this one, I get 2x minus 1. If I divide this one by this one, 2x minus 1 cubed goes away. I get minus 4 times 2 times x, minus 8x. And I notice this is 2x minus 1, this is 2x minus 1. These two cancel each other. This completely goes away. And this one, 8 minus 3, 5. So the denominator is 2x minus 1 to the power of 5. What is the numerator? 2x and minus 8x. They add up to negative 6x minus 1. And the final answer, y prime, is minus 6x minus 1 over 2x minus 1 to the power of 5. Fairly simple. Y equals 4 over square root of x squared plus 3. Anytime the numerator is just a number, we don't have to use a quotient rule. We bring this up, we make it x squared plus 3 to the power of negative 1/2, because square root of x is x to the power of 1/2. This is to the power of 1/2. Bring it up, make it negative. Get it ready for the extended power rule. So obviously we start with 4 when we want to differentiate. Times negative 1/2. X squared plus 3, we're going to raise it to the power of minus 1/2 minus 1, negative 3/2. And now here's the chain rule, the derivative of the inside, 2x. We're done with calculus. We are going to finish the job with algebra. 4 times negative 1/2, negative 2 times 2, negative 4x. We can take this down and make it positive 3/2. Remember the negative exponential rules, the way you move things around, and you put it back in the square root format you received it. So y prime is minus 4x over the square root of x squared plus 3 to the power of 3. What about y equals cosine 3t to the power of 4? I want to mention a couple of things. Number one, reminding you that the derivative of sine is cosine. But if it's sine of u, you can say cosine u du dx. If it's sine of g of x, you can say cosine of g of x, g prime of x. This is the nature of the chain rule. If you're dealing with cosine, the derivative of cosine, you should know it's negative sine. The derivative of cosine u is negative sine u du dx. And the derivative of cosine of g of x is negative sine g of x, g prime of x. These two, of course, just as these two refer to the chain rule. So the way I approach it, as I mentioned it before, when I'm dealing with trigonometric functions in general, I like to read and pause. Cosine, and I'm going to stop. If y equals cosine, its derivative must be negative sine. Then this is meaningless without an argument. So you use the same argument, 3t to the power of. And now, if this is t or x or theta, you're done. But it's a function of t, and that means g prime of x, or in this case, g prime of t. That means you have to differentiate using the chain rule. That gives you 12t cubed. You put that in front, and that becomes the final answer. So y prime is negative 12t cubed, sine of 3t to the power of 4 as the final answer.